Alright, we're back. It's the next day, and I've already been through quite a few things on the code, trying to sort out stuff. This protocol document, other than the initial part of just simply knowing what codes to send and the general structure of the data, it lacks so much information that I'm basically having to go through now and empirically set up things on the meter so that I can then get the parameters that it generates as an output and then code them in. So this is not unusual. It happens fairly often. I mean, whoever wrote this originally, they did a great job in the sense that they got things started. But often what will happen with these projects is that once you've got what you're after, you stop bothering to do any more updating of the information that other people are going to use. Like I said, I mean, why bother? No one's paying you for it, and you're not going to get any fame, really. So, yeah, once your job is done, it's done. And the same is pretty much going to be here for me. The only upside is because this will be going out as a open source code, then other people can utilize that. So anyway, we'll get on with it. We've just been doing capacitor tests. So see, I've got a 47 microfarad cap. Yeah, so this is one of the first meters I've ever bothered to do capacitor tests with. Handheld multimeters just generally seem to just suck at capacitor tests. So we'll just put a great big fat green cap on there. There's that. And so what will happen is, well, we'll put the smallest one on. I think this is a 47 nanofarad. So a teeny tiny thing. And it helps if I don't disconnect it. Yep. Okay, 58 nanofarad. I wonder what is it supposed to be. If only I could read. And I don't know what I've done with my magnifying glass. Man, I hate the fact that I've turned into an old person now, with vision issues and stuff like that. Okay, I'm not really that old. Not quite 50 yet, but definitely already the eyes are not as good as they should. And this actually is a 56 nanofarad, so I can just read the code up there. So that's not bad. 58, that's pretty good for capacitors. So what I've been doing is, you'll hear this as I cycle through. Let it go into auto mode, and then I hit the range button and force it to cycle through the different ranges. So we just keep going until it loops all the way back around. So out of range. And I think we're basically back where we were. And with each transition I then note down what the data is showing on the screen up here. And then I have to manually work out how the mappings occur. So in this case you can see we've done the capacitance, and this is the range data. The range data is only, I'm setting it up there at the start, but that's more of a baseline. You'll find a lot of the modes actually react differently according to that range data, which is why we have things like this decimal place position adjustments and things like that. So I need to do resistance now. I was sort of mucking around with that, couldn't quite get it right, so now I'm going to hopefully get it right. So we'll switch over to ohms mode. So we got 10k resistor in there. So as you can see, it is showing up correctly for that, but that's in auto mode. So that's correct. The mega ohms. Okay, so the mega ohms is wrong because on the meter it should be, it's reading 0.0095, where I don't have a decimal place up here. And so we're just going to stop that sequence. And you can see here we got DPP5, and I know that I need to have it at 0, so let's see. And we need the decimal place dropped. Well, the default seems to be kilo ohm measurement with 2, so there's probably going to be an ohms one as well that we'll have to work out, so I'll have to get some other resistors for that. Okay, so we actually need to drop that down to 5. Alright, so now that is actually matching what is on the display. Should we 0.08? And now that's wrong too, so DVP6, it behaves differently yet again. There probably is an algorithmic reason, I can't think of it. What have I got? I got that wrong. That's weird. Technically that should... Ah, that's correct now. Okay, so it seems I have a feeling probably 1, 2. There's no prefix for 1 and 2 most likely, probably even 3. We'll go get ourselves a small resistor. No, we've got one here. So, what have we got? Okay, these are 0 ohm resistors, or links. Links with a bump in them, but just shaped like resistors. Some people think, what's the point of that? Why not just have wires? Well, the thing is, if you have a board and it's been populated by a machine that handles resistors, then by having a link shaped as a resistor, it means it's there's no interruption or no behavior changes required by the machinery. So what do we got? We're reading 0.0878 ohms. I wonder how accurate that is. Okay, so we're 1 decimal place too far. See where the next one is. Range. Okay, it goes straight to k ohms. DVP2. Looks like I was wrong about it, maybe going up. Okay, that's correct. 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 No, that's correct too. Yeah, it looks like there's only one ohms only range, and yeah, alright. That low value it was showing, I don't think that's legit. I think it's sort of like a noise floor or just a floor. I'm going to see if I can find something like a 2 ohm resistor. There we go, 2 ohm resistors. This is slightly heftier. Let's see what our range is out to. I gotta admit, I'm pretty impressed. 206. So it looks like that 0.054 to 6 or something like that. The 10 milliohms type level seems to be the limit of its resolution. So that means we probably can easily pick out, yeah, tenths of an ohm, which that's not too bad. What we'll do is we'll put 2 of these in parallel and see what happens. Okay, I might have a... What's this? 150, 12, 20, 2.2. That'll be a good test. So the other ones are 2, as we want, now we've got a 2.2. 2.2. So 2.26. Yeah, that's pretty good. Yeah, it's definitely. I'm thinking that that last digit there is basically something you can ignore. I wonder if you can actually zero that out. There might be a way. I suppose I could do that in software actually. If I find out, okay, that what is it, 40 milliohms can just be deducted from the value. Although it's probably temperature dependent and among many other things, so it's, come to think of it, probably not even worth doing that. Alright, so that's the ohms range sorted out. Can we optimize this to make it a little easier to see? Yeah, I think we'll just leave that as it is. Current range, yeah, I haven't really got the stuff I need to test that. And I have not got my precision references for the voltages to test either. We're just going to have to leave those as is. Alright, let's get rid of this code that we don't need. Now the next thing I want to work out is how to put a second line on this. It's going to be a little bit tricky because I need to have a smaller font. I can't use the same size font. Which reminds me I need to take away that twice width version of code that I put way up here somewhere. There we go. Good. Switch over to temperature. Some slightly ridiculous values there. Interesting, they put the Fahrenheit as a secondary display here rather than the primary, which I'm glad for because, I mean, hey, I am in Australia, and like most of the world, we do use degrees, or centigrade rather. I don't think you're supposed to say degrees centigrade anymore, you just say centigrade. Freedom height temperatures are not acknowledged here. But for those wanting to know, that's 78.15 freedom heights. Let's pick up our frequency. So that is picking up just simply from the air. That's the mains frequency. So you can see, if I ever forget what the mains frequency is in Australia, just turn on my meter and it will tell me it's 50 Hertz. Alright. I think we're pretty much... yeah, this is the bulk of the initial code done. One thing I did find out was I was using this USB adapter. This is a genuine FT232R type. I'm pretty sure it's an R. Anyway, it's a genuine unit, but it was giving me grief. You may remember last night on the earlier section that every fourth or fifth line that was coming out had different data, and it was like it wasn't consistent. And it would crash quite frequently. Just, well, I wouldn't say crash, it would just lock up. I couldn't send serial data properly anymore. And I think what the problem is that the multimeter is depending on the serial port to power the opto isolated side, or its own side, the isolated side, whereas this particular USB cable is not doing that, at least not a high enough voltage. Maybe it's only sending 5 volts and it's expecting to have 10 volts on it, which would be, I think, is the minimum standard for proper RS-232. There is the TTL RS-232, which isn't really actually RS-232 as such, as far as I understand. But I may just simply have to find a different adapter. I know there are some out there that have a superior high voltage powering of the pins. In the meantime, fortunately with the machine I'm using, it does have a dedicated serial port, so I plugged in and it was all okay. Okay, so our frequency is dropping slightly. It must be a load on the network. Let's remove our sleep time and see if we can still crash it. That's some seriously fast updates there. Especially having a millivolt. That's certainly pretty much as quick as the B-side ADM. Yeah, B-side ADM 20. Maybe not actually even as quick. No. I think the updates are actually fractionally slower on this. This is around about 3 to 4 updates a second, whereas the B-side handheld was closer to 5 to 10. That's interesting. I do wonder though whether this is on the slow mode. Looking at the display, it actually doesn't update any faster than that, funnily enough. Let's see if other modes are quicker. No, it's definitely display limited. It's not... yeah, I don't know if there's a faster mode. Because if that's using full 80,000 count, then I can understand that. I mean, it's not a major issue. It's interesting in the diode mode, it's actually saying on the display, it's saying open. So we'll stick something like a 10k resistor in there, see what happens. Unless that is actually meaning continuity verse. Oh yeah, that continuity is fast. So here we go. That's pretty much instant. That's very fast. And let's see. Well, the screen updates might not be as fast, but the continuity definitely is very fast. Not sure what its limit is though. Let's have a look, see if we got that. This is the 2.2 ohm resistor. Let's see if it thinks that's a short. Yep. As it damn well should. think I've got a 10 ohm or 12. Okay, I've got 20 ohms here. Depending on the meters, they vary between 20 ohms and 30 ohms. It thinks 20 is still shorted. What does that represent in terms of diode mode? 0.01. Makes sense. Yeah, 47 ohms. That's interesting, the can you hear that? That's so close to marginal that it just makes a slight noise. That could actually be useful. That's an interesting sort of feedback. The closer you get to the short, the more intense the beep, which they often do with short finders. Alright, let's stop that. Let's have a look and see what we can do about getting a second font built into this. So my guess is we would load another font. Oops, there we go. We'll call that small. And we will set it to be, let's say, a quarter of the size. Okay, I think we can do this. It looks like when we render the text, it just calls in the font in question. So we're going to say line mode. What the? I don't know, what happened then? Cap locks on? No. I'm not sure if this is going to work, whether I have to do these separately, but let's give it a whirl. Small, line 2. I think I can already see I am going to have to do them separately, or at least staged over each other. Probably doing this wrong. This should probably cause a core dump. Line 2 is not declared. Lovely. Interesting that in our copy we don't specify the source. Okay, source is the entire texture. So if we do this again, but for the second one, so let's see. Is that you? And this should theoretically overlay. Yeah, this should theoretically overlay the text onto the top of the other one, at least initially. Textures, no, it's underscored. And it does. We could just leave it there. Let's see. Names. Resistance is futile. Temperature. Good. Okay, I might change the millivolt mode to back to volts. I just noticed volts AC is wrong. That should be 1.1 volts. Oh boy. Which interestingly is what we have to do the VDC volts to. So resistance between my fingertips are. Yep. Alrighty. Well, it looks like Openbroadcaster's having a field day of not working properly. I think unfortunately this particular machine that I'm using for my workstation is an i3-4160. Doesn't quite seem to really keep up, which is kind of unusual because I had a I think it was a 3rd or 4th generation Pentium, and it was working perfectly fine for this sort of thing, so I'm not really sure what's going on there. Maybe with that really large block of text there it got upset, but maybe it's OBS, maybe, I don't know. I often used to use Voco screen for capturing what I was doing, but I do have my little web camera on this, so maybe that's at fault. Either way, I should probably upgrade to something like a 6th generation i5 at least, but then if I'm going to go that far I may as well go i5-8400 or something like that. Okay, well, looks like the meter for the most part is now done. There are some minor things to flesh out still, some modes that I'm not personally using. Again, this is like what I was talking about with the documentation, is once you get to the point where you're happy with it working, you sort of just walk away and say, I don't give a crap. But it's working. For now we do have to use a dedicated serial port until I can find a cable that will properly drive the optoelectronics on this multimeter. It could be a case of the current demands of the opto isolation too high for what's being provided by the adapter that I have there. That's this one here. I'll try a few others. I have, like I said, seen some dedicated for this sort of purpose. We'll just have to keep at it and see if we have any luck. My other option is to actually rip out the one that's in there now in the meter and replace it with my own USB adapters, but that's probably more drama than I want. I want to do as minimal amount of modifications that I can get away with on this meter as I can. I want to be able to have it so that people can go, okay, look, I want a cheap meter that's going to sit on my bench and work with Openbroadcaster and do what I need for board repair with as little work as I need to have it up and running. So at this point I'm going to clean up a few more things, then send that up to GitHub, and we'll see how we go from there. And maybe on the next, hopefully on the next live stream, or not live stream, what am I talking about? On the next board repair, I'll have this set up on the workbench, and we'll finally be able to give it a whirl and see how it works in the real life. Until then, you'll take care. I'll see you next time. Hey everyone. Well, it's been about an hour or two since I finished up the last ending of the video, and I was running around trying some large font size, about 200 pixels and whatnot, and crashed my system pretty damn solid and hard, and it was a real hard drive thrashing, so I thought something's chewing up memory like anything. And in the end I found out that I was just constantly creating new surfaces and textures, so whoops, yep, my mistake. That's what happens when you cut paste things occasionally. Anyway, so managed to clear that away and added some modes. What else? We can also now quit cleanly out just by hitting the letter Q, and there we go, closes up. So yeah, things are improving, and over the next few weeks I imagine things will get better. But yeah, so in case anyone was having an aneurysm thinking that I wasn't freeing things, well, you were right, but anyway, it's all fixed up now. Anyway, take care, I'll see you later.